right? So we'll just read through these notes here. Scale drawings represent the actual size and shape of an object on a paper. Okay, so very large objects are reduced while very small objects are enlarged by a ratio called the scale factor. So let's look at the example here. The Umhlanga Lighthouse in KwaZulu-Natal is 21 meters high, and this large structure would need to be reduced on paper, for example, by a scale factor of 1000 as shown below. So what we're saying is that if something is measuring 21 meters, we can't actually draw that on a piece of paper. We would need 21 meters of paper, which is impossible to do, right? So what we do is that we make the smaller drawings, but then on the drawing there you'll have a scale that's going to tell you how much does each centimeter measure. So in this diagram here, all that it means is that each centimeter here is measuring 1000 centimeters. So then when you work it out, then you will get the actual size of the drawing. Okay, so there's two types of scales we're going to look at: a numerical scale or a number scale, and a bar scale or a linear scale. So today we're concentrating on having a numerical scale. Okay, a numerical scale is this one here, where it's written in a ratio, and you can see that the drawing is telling you at what scale this is drawn in. You guys probably maybe did it in geography. It's the same thing, where you have a map, and then you have like for every 1 centimeter, they tell you that it's 1000 centimeters or 1000 meters. That's called a numerical scale, and that's what we're concentrating on today. Okay, so we're looking at what is a numerical scale, right? So I've used an easy example here to explain it to you. So this one is saying that I have a numerical scale which is 1:50. Okay, what you need to know is that this is actually shown as a ratio, right? So you can see it's saying 1:50. Okay, so what the first part tells you is the size on the map. Okay, so if we're talking about centimeters, it's telling you 1 centimeter on the map is 50 centimeters in actual length. Okay, so the second part of it tells you the actual length of the object, right? So if you have an object that's 50 centimeters, or 1 centimeter, and it's showing you 1 centimeter on the map, it means in reality it's 50 centimeters, right? And this is the part that we call the scale factor. Okay, so if you learn it like that, I find it much easier to do the conversions. So we call this part the scale factor, right? So every 1 centimeter on the map is 50 centimeters in this example here, and this part here is called the scale factor. So it's telling you how much is it equivalent to, right? And remember, we're doing ratios. So ratios have equivalent units. So if you're saying 1 centimeter, you have to compare it to 50 centimeters. So the units must be equivalent, centimeters and centimeters. Now look at this example here. It's in that book there. I'll show you the picture. It's a pay station, right? So the size of it is, they're telling you here that the length of it is 3 centimeters. Okay, so if the length is 3 centimeters, but the scale on the diagram is telling you that it's 1 centimeter is actually 22 centimeters. So this part is called your scale factor, right? That's 22 here. So what my question is telling me now is that I need to get from the map to the actual length. So if I have 3 centimeters in my drawing or on my map, and I want to know according to my scale in reality what's the size of that pay station, right? My actual length, I'm going to say my map length, which is my 3 centimeters, and I'm going to multiply by my scale factor. So I'm going to multiply it by 22, and I'm going to get 66 centimeters. Okay, can you see what I've done? We've gone from the map to the actual size. The map size is telling you that they have drawn it to look like 3 centimeters, okay? But the actual size of that base station's length is 66 centimeters, right? Now if we're going the other way around, right? Now they're telling you that the actual length is 150 centimeters. So they're telling you that this part here, in reality, if the actual thing is 150 centimeters, and they want you to draw it to scale, where your scale factor is 22, but they want you to change it to a map or a drawing that's going to have a scale of 1:22. So what do we mean by that? We're going from the actual size to the map size. We're scaling down, right? So you're going to take your actual length, which is 150 centimeters, and then you're going to say divided by 22, and your answer is going to be 6,82 centimeters. Okay, so then now we found the map length. So the actual length was 150 centimeters. We've gone to 6,82 centimeters. So if we want to draw it with a scale of 1:22, we're going to draw 6,82 centimeters to represent that 150 centimeters. Can you see the difference between the two calculations? The first one is we're moving from the map to the actual. So we've been given, it's already drawn to scale.